So this is a report on progress so far in our G2P work stream, which is all about um, ensuring alignment between Mojaloop and the broader community in the delivery of social payments and payments through uh, banking systems. So we have MiFOS in there, and through digital identity systems, and there we have MOSIP, and of course working with OpenG2P in the actual delivery of or the specification of social payments. So next slide, please. Yeah, we are a member of the Digital Public Goods Alliance. We've been working with them for more than a year now, and up until recently, it was all about essentially assessing each other and seeing how well we could interact. And then we took the initiative and decided to actually propose a demo, a proof of concept of how these various open source projects could collaborate in the delivery of social payments. And the key members here that we are actively working with here is obviously Mojaloop ourselves, MOSIP, which is an open source digital identity solution, which is being adopted by a number of the countries that we are focusing on, and Fineract and MiFOS for essentially an open source banking back office solution. Can we move to the next slide, please? So before we get into what we have done, I wanted to give people an intro to social payments as they generally work, as a backdrop to the discussion, and then we can look to see how we've addressed that in our proof of concept work so far. So at the top we have government or NGO. That it's essentially a large organization that wants to make a set of social payments, and generally this is multiple bulk payments of anywhere from 1,000 to 1,000,000 payments. Think COVID relief, for example. And the first step in that is to define the criteria that the organization wants to make payments to. So people who meet this criteria will get $20, for example. And they generally use a beneficiary management system to do that, or historically Excel. But we're trying to move on from that, and we have OpenG2P, for example, which is a beneficiary management system. And in the beneficiary management system, you register people, our little green person down at the bottom and the red person on the right, and you collect a whole bunch of data about them, demographic details, size of families, age, gender, income, etc., etc. And you take that registration database and the criteria supplied by the government, and from that build a list of who is to be paid and how often. So you build bulk payments lists, and the bulk payments lists are then forwarded to the bank that can support bulk payments. And at the same time, the government actually provides the funds to the bank to support those payments. And then the bank will then, in our scenario at least, integrate with Mojaloop to initiate all of those bulk payments. And the switch, Mojaloop, will hit the Oracle to see where those payments should go, whether it's our green person who has an account at an MFI or a red person who has an account with a mobile wallet. The issue is how to reliably identify the DFSP account in which to deposit a social payment. And that relies on updates to the Oracle. Now, in the past, this has been done by mobile phone number, MSISDN, but that's kind of unreliable. People change their numbers, people change their mobile wallet providers. And in many countries, such as Myanmar, you have many mobile wallets associated with the same mobile phone number. So we look to see, can we use other aliases? And an obvious one is actually a national identity number. So all the government needs to do, or an NGO, is when they're registering people, they can show their national ID card, for example, and register that with the beneficiary management system, and then we can route payments to whichever account is selected for that national identity number. And that's the background to this project. We wanted to create a proof of concept which will implement that. Next slide, please. And Paul, I think over to you now.
Thanks for that context, Paul. So for starters, I would like to say we ran this project a little bit different to before, this work stream. Well, it's not that different to before, but we've really got a community effort here. So the real building of the core components were not done by Infotex. They were done by Spark Systems. Raise your hands. Where's Spark? The guys at the back. I'm going to get them to come up and they're going to be giving a demonstration later, so you'll get a good look at them. But well done. They built the beneficiary management portal. And then Elijah, where's Elijah? Ah, there you are, Elijah. Elijah is rapidly becoming our systems integration sort of expert consultant. He built a lot of the integrations into MIFOS for us. Yeah. Yeah, it's nice to be working in a community environment like that. So a little bit about this project. I both love and hate it. I love it because I really think it's going to have a huge impact, but I hate it because we keep on coming up with a better design. And that involves a lot of rework and reorganization, and so it's a pain. But we do that because each time we come up with a new design, it's actually a lot better. It would have been obviously nice if we just thought of the really good design in the beginning, but that's not always what happens. So this has been an evolving design, and at the moment we've got a new one. So if you've seen this before, still stay tuned because it's probably different. So the first part of this new design is we are implementing a personal alias. So what do we mean by a payment alias token? I thought it would be good to spell it out. So payments alias token, it is a token, a payment token linked to a person. Okay. Then secondly, it is a payment token that can be provided to people to make payments to that person. And in our use case here, the beneficiary system can use that token to make payments to the person. Then the person or party, we also call people parties in Mojaloop, can change their account to a different account provider. And that token can still be used, and it'll then pay a different account provider. When we allow that person to make that change, we remake some of the KYC checks to make sure that the account does actually correspond to the person. So that's high level what we mean by a payment token. Then the next part of this design is we are layering the payment alias, the payment token alias, on top of an existing payment token inside Mojaloop. And the reason why we're doing that is some tokens are easy to put in place because they work with bank accounts and sort of relate to more sort of traditional payment infrastructure. And I've got some examples of these here. We've got an MSISDN, we've got account ID, and we've got IBAN. These are examples of Mojaloop payment token identifiers that would be applied to this. And so what we are doing is we mapping our alias onto one of these existing payment token aliases. And here we also do a KYC check, validation check. Now, you don't always want to do a KYC validation check in a beneficiary payment. So let's say you're providing a beneficiary payments because of a disaster in a particular area. If you're doing that, you probably don't mind if the people withdraw their funds from one account to another. You know, if it's their sister's account because that organization had cash, you're going to let that happen. Uh, but sometimes if it's, for example, a social payment, then it's really important that certain KYC elements match. And that level of matching depends on the scheme and the data that's available to be matched, and also the implementation of MOSIP as how much data is available. But it should be configured per beneficiary system connecting to the system. So the beneficiary decides on the level of matching they need for the tokens that need to be generated. And the way we do this KYC matching is the MOSIP provides KYC in their backend. So this beneficiary management portal becomes a MOSIP partner, which allows them to access the KYC data. And then we use the Mojaloop discovery core, which then provides a certain limited information about the party. Now, at a high level, at the basic level, that might just be the person's name, which is at least something. But in some cases and in some scheme setups and some scheme rules, that can be extended into things like date of birth or address or other information that might be really important to match. So we do MOSIP call and we do a discovery call, and we can make sure that they do correspond. And when that information corresponds, then we register this token and we let all the parties know. And that's why we can also allow the individual person to change their bank information if they need to, provided the same set of checks are done later. So let me take you through a walkthrough on how this should work. So what we've got in this diagram is we've got the beneficiary management system that is initiating the payments and keeping track of the parties involved. Then we've got MOSIP, which is the identity system. It is often deployed as a countrywide identity system to help identify users, and part of the implementation of MOSIP is discovering a reliable way of allowing them to log in and validate that they are who they are into the MOSIP system. So we're going to be leveraging that system. Then in purple in the middle, we've got a token registration portal, and that's the part that Spark Systems built. Then we've got Mojaloop down below, and we've got the bank. That bank there is the beneficiary's bank that they're using to make those payments. And we've got the payee bank account, which in this use case is a MIFOS backend system, where they're going to be receiving these payments and directing the payments to the correct account. So how does this work? The beneficiaries go to the beneficiary organization and apply to get some sort of beneficiary payment. And then in setting up this token registration, the beneficiary management system does an open ID connect redirect connect. So this is like identity access systems used for logging in, performing a remote login system. So we're using the same standardized mechanism to redirect to this token registration portal. So in this token registration portal then goes to MOSIP and gets the user to identify themselves and log into MOSIP. And then we perform a discovery call. They do select the payment token that they need, that they would like to link. And then using that token information, we do a discovery call into Mojaloop, which then goes to the account holding institution and gets the KYC information that we're going to be needing to validate that that token is going to the person. So we do some KYC checks, and then we create the token, and then we register the token. We register it both in Mojaloop, and we register it in the payee organization, so that they know how to map that token to the real organization. And then we return that token back to the beneficiary management system. So this token now means something. It means that we've found an account and we've validated that account information exists, and we know it belongs to the person who's registered inside MOSIP. And that allows the beneficiary management system to make a payment using that alias token generated in Mojaloop. So there's two parts to this. There's the token registration. So this is a sort of a more detailed schema diagram of architectural diagram of the components. So beneficiary management in the system, the part that Spark Systems built, and it is talking to MOSIP to allow them to log in. It is triggered from the beneficiary management system from above, and then it makes a discovery call into Mojaloop through a payment manager connection to validate that account information and get the name of the person provided. And then it generates a token, and it does token registration by calling the post accounts that registers the alias token inside Mojaloop, and then it calls back to the token and it registers the token in the payment token adapter. Now, let me explain the payment token adapter and the thinking behind that. So what we're effectively doing is we're mapping one alias for another. Well, not one alias, we're mapping the alias to a standard Mojaloop payment token. So what we've done, and this is the work that Elijah's done, is he's built a payment token adapter that performs that action. And the reason why we did that is we can then install it in between the core connector and the Mojaloop connector, and it'll then make that translation. So it handles the registration of that mapping and then applies that mapping to API calls coming through. And in other words, your existing payment integrations will work. All you need to do is deploy the payment token adapter and then register that endpoint for registering at the token registration portal. Now, this is not an ideal flow, and I'm hoping that in the future we'll be able to extend the Mojaloop API so that we can manage this concept of an alias mapping to another payment token. And if we do so, we wouldn't need this direct connection back to the participants integration layer. But this is a reusable component. So then how does a payment work? This is the second part of it. We've got a beneficiary system as the payer. It then connects through payment manager and Mojaloop connector, which connects to Mojaloop, and that forwards the payment on to the connection manager, which goes through the payment token adapter, which then maps the alias, the token alias, into the IBAN. That's what we're using in this example. There's an IBAN, and that IBAN then sends to the MeForce core connector, which then knows which account to credit inside the MeForce sandbox. So I think we're ready for demonstration time. So I'm going to invite Elijah and James, and I'm actually not that involved in organizing how they're going to do this demonstration, so I better let them come and take over. Lastly, at the back of the slides, we've got some links to the work, to the epics and references. So if you want to follow along, please, that's where you do it.
Hello. So just like what Paul has already explained, so on the screen, as you can see, this is the beneficiary management system. So from here, we have a list of all the beneficiaries that, say, for example, the government has, and maybe they want to make a payment to a particular individual. So before that particular payment is made, there's a need for a token to be registered first. So to do that, you just come here and click on the register token button. When you click on the register token button, you are redirected to the beneficiary registration portal, which upon getting there, you're redirected to MOSIP. So we use MOSIP to verify the credentials, whether this particular individual indeed the information that that is present in MOSIP matches with the information that is present in Mojalo. So to do that, you click on login with OTP. Here you provide the unique identifier. So you have to verify that you're not a robot. Then you click on get OTP. So the OTP is sent to your phone number or the email address that you registered with. So simply put in the OTP. When you put the OTP, you verify. Yeah, so here, once you provide the correct OTP, you are redirected back into the beneficiary registration portal. So in the beneficiary registration portal, you put in you first of all select the payment type. So it can be MSIDN or it can be account. So for this demo, I'm going to use IBAN. And under the payment number, you select the number that you want to associate the token with. Then you click on register. So as you can see, we have feedback here, which says, first of all, it validated that indeed the KYC from MOSIP and also the KYC from Mojalo matches, and then it generated the token, and then it registered the token, and then it posted the token also in Mojalo. So from now, my friend Elijah will demonstrate on how you can now make use of that particular token that was generated to make a payment.
Good afternoon, everyone. My name is Elijah Keller. So I'm going to demo how a payment can be made to the just registered user. So the idea behind this is that the government should be able to make payments to people that have accounts in microfinance institution. So in this particular POC, the microfinance institution is being powered by a FINERACT backend. FINERACT is an open source core banking system that is built and maintained by MIFOS, but they donated it to Apache Software Foundation. So for this demo, I'm using the publicly hosted instance of Apache FINERACT, which has been made available for testing purposes. So they have documentation on what is the username and password to use to authenticate with the API. This user interface you're seeing here, I just built it to read from the API, the Apache FINERACT API. So this is the FINERACT API. That's just a read of the current account. The user is called, I hope you can see very clearly. That's the account number. And the name of the user is this. So I just built this interface to render out what is picked for purposes of seeing it in a better way. So he has finished registering the payment token for the beneficiary that is supposed to receive the funds. So what is going to happen is I'm going to initiate a payment from the payer payment manager that is deployed in a secure deployment of Mojalo. I've been running tests a lot of times, so I'm just going to run this payment again. And what we should see is we should see this account balance of this person increased by the value of the amount of money that we've transferred, right? And that's the goal, because we want to see a payment come from whoever is making the payment, whether it's an organization, an NGO, or government, to the person. So let me go ahead and execute the transfer. Okay, I'm going to hit that. I'm going to hit send and it should start working. What is going to happen in the background is that when a transfer comes from the payer, that is government, the request, the account lookup request is going to go to Mojalo, and Mojalo will do an account lookup for that particular account that is inside the IBAN string that was registered by the beneficiary portal. After that, the Mojalo switch will make a request to the payment token adapter through the connection manager. The payment token adapter will switch out the details and transfer the request to the MIFOS core connector. What the MIFOS core connector will do will then make the corresponding lookup requests to the Apache Fineract deployment. Once it has made those requests to Apache Fineract, Fineract will reply with the client details, that is the details of the account, to fulfill the account lookup. After that has happened, it will then make a deposit on the account of the user. Ideally, what we're supposed to see is a payment sent from the payer, which is government. Once that payment is sent, it should be credited on the user's account. Now, the user account that we're using is embedded in the IBAN string that was registered by him in the beneficiary portal. So once we have all that set up, we should be able to see the account being credited.
The team has really put a lot of effort in here, and I think we need to give them a round of applause for trying to do a live demo in a poor network environment. So well done, guys.